Can a chemist and physicist be friends? Chemist, a scientist specializing in chemistry. Physicist, a scientist specializing in physics.
Hi, I'm Martin, a physicist.
Hi, I'm Pothin, a chemist.
I'm Goblaska, an atom who would like to visit these scientists. Hey guys, I'm Adam. I bet you're into physics and chemistry, right? You were probably thinking about me. So here I am. What are you curious about? What do you want to know?
Wow, what an arrangement.
Wow, what a force.
I'm the chemist. How electrons are arranged in you. I also wanted to know how distribution of electrons in its outermost shell directly determines your chemical behavior. Also, how atoms interact to form molecules.
Okay, I'll answer you first. I'm not getting into Thomson, Rutherford, or Bohr here. Let's chat about the quantum mechanical model that Schrödinger and Heisenberg came up with in the 1920s. This model ditched the whole idea of fixed orbits and went for probabilistic orbitals instead, which are just areas where electrons are likely to be found. These orbitals are organized into subshells, S, P, D, F, that have their own shapes and energy levels. Your first question is how electrons are arranged in me. So if I'm sodium atom, then 1 valence electron in the 3s orbital, and if I'm oxygen atom, 6 valence electrons in the 2s and 2p orbitals. Got it? Before answering the next question, let me just explain octet rule. The octet rule says that stability is achieved by gaining electrons, losing electrons, or sharing electrons. The octet rule refers to the tendency of atoms to prefer to have 8 electrons in the valence shell. When atoms have fewer than 8 electrons, they tend to react and form more stable compounds. Now your question on how the valence shell determines behavior? Answer is, chemical bonding. The 3 primary types of chemical bonds are, ionic, covalent, and metallic. Ionic bonds occur when one atom completely transfers electrons to another, creating oppositely charged ions that attract each other. Covalent bonds occur when atoms share electrons to form a stable molecule. Metallic bonds occur in metals where electrons are delocalized and shared freely among all the metal atoms, creating a sea of electrons. Any questions?
You have answered my questions, thanks.
Can I ask my questions now?
Sure, go for it.
As a physicist, my interest is on the center, the nucleus, and what forces binds them all together. Also want to know about the wave nature of electrons too. I mean, why they spin around nucleus like that?
Let me first answer your second question. Electrons don't literally spin around the nucleus like planets orbiting the sun, as earlier classical models suggested, for example, the Bohr model. Instead, their behavior is governed by quantum mechanics, which describes them as existing in regions of probability called orbitals. Now the question on electrons as waves. Electrons exhibit wave-like behavior due to their tiny size and high speed, de Broglie wavelength. Electrons have a wavelength inversely proportional to their momentum. Wave function describes the probability of finding an electron in a certain location governed by the Schrödinger equation, which predicts electron behavior in quantum systems. Uncertainty principle. The Heisenberg uncertainty principle states you cannot precisely know both the position and momentum of an electron simultaneously. This is why we describe electrons in terms of probabilities, not fixed paths. Now, coming to the first question, the nucleus is the central part of an atom, containing protons and neutrons, collectively called nucleons. Despite being incredibly small compared to the overall size of the atom, the nucleus contains almost all of the atom's mass. Its structure is held together by fundamental forces, particularly the strong nuclear force, which counteracts the electrostatic repulsion between protons. Forces acting in the nucleus are strong nuclear force, electromagnetic force, weak nuclear force, and gravitational force. Gravitational force is negligible in the nucleus due to the extremely small masses of protons and neutrons. Any more questions?
Lots, but thanks for the introduction.
I guess physicists and chemists can totally be friends with atoms.
Yeah, have a nice learning time.
Thanks for watching.